Chapter number 10, Atmospheric Circulation and Weather System. Atmospheric pressure. The weight of a column of air contained in a unit area from the mean sea level to the top of the atmosphere is called as the atmospheric pressure. So what is atmospheric pressure? Atmospheric pressure is the weight of a column of the air contained in a unit area from the mean sea level to the top of the atmosphere is called atmospheric pressure. The vertical pressure, next point, the vertical pressure gradient force is much larger than that of the horizontal gradient force, but it is generally balanced by a nearly equal but opposite gravitational force. Hence, we do not experience strong upward winds. So why we don't experience strong upward winds despite vertical pressure gradient force being much larger than the horizontal pressure gradient force? Because vertical pressure gradient force is generally balanced by a nearly equal but opposite gravitational force. Next point, horizontal distribution of pressure is studied by drawing isobars at constant levels. Isobars are lines connecting places having equal pressure. So what are isobars? Isobars are lines connecting places having equal pressure, and horizontal distribution of pressure is studied by drawing isobars at constant levels. Next point, low pressure system is enclosed by one or more isobars with the lowest pressure in the center. Here we are talking about low pressure system. So in low pressure system, the low pressure system is enclosed by one or more isobars with the lowest pressure in the center. High pressure system is also enclosed by one or more isobars with the highest pressure in the center. So in low pressure there is lowest pressure in the center, in high pressure system there is highest pressure in the center. Next point, equatorial low. The 30° north and 30° south of the equator are known as subtropical high. The 60° north and 60° south of the equator are known as subpolar low, and poles are known as, both poles, north pole and south pole, are known as polar high. Equatorial low is at 0° at the from where the equator passes. These pressure belts are not permanent in nature. They oscillate with the apparent movement of the sun. These pressure belts are not permanent in the nature, and they oscillate with the apparent movement of the sun. In northern hemisphere, in winter they move southwards, and in the summer they move northwards. Next point, forces affecting the velocity and direction of the wind. The horizontal winds near the earth surface respond to the combined effect of three forces: the pressure gradient force, the frictional force, and the Coriolis force. In addition, the gravitational force acts downwards. So what is pressure gradient force? The difference in atmospheric pressure produces a force. The difference in atmospheric pressure produces a force. The pressure gradient is strong where the isobars are close to each other, and the pressure gradient is weak where isobars are apart. Next point, frictional force. Frictional force affects wind speed mostly up to 1 to 3 km. Frictional force most affects the wind up to the 1 to 3 km from the surface of the earth. Over the sea surface, the frictional force is minimal, SEA, not SEER, SEA. Coriolis force. Coriolis force deflect wind to the right in the northern hemisphere and to the left in the southern hemisphere. The deflection is more when the wind velocity is high. Coriolis force is directly proportional to the angle of latitude. That is, more the angle, more the Coriolis force. More the angle of latitude, more the Coriolis force. It means the 0° latitude at equator, the Coriolis force is also 0. So maximum at poles which are 90 degrees and 0 at equator. So Coriolis force is maximum at force and 0 at the equator. Coriolis force is perpendicular to the pressure gradient force, which is perpendicular to the isobar. Higher the pressure gradient force PGF, more is the wind velocity and larger the wind deflection. As a result of these two forces operating perpendicular to each other in the low pressure areas, the wind blows around it. At equator, there is zero Coriolis force. Wind blows perpendicular to the isobars. So there is no Coriolis force that is perpendicular to the pressure gradient force. So the low pressure which develops gets filled instead of getting intensified. That is why no cyclones are developed in the equator. This is the reason why cyclones are not developed in the equator, because at equator there is zero Coriolis force and wind blows perpendicular to isobars. Low pressure gets filled instead of getting intensified. That is why no cyclone is developed in the equator. Next point, pressure and wind. 2 to 3 km above the surface of the earth, winds are free from frictional effect of the surface and are controlled by the pressure gradient force and Coriolis force. When isobars are straight and when no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobar. This wind is known as the geostrophic wind. So what is geostrophic wind? When the isobars are straight and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobar. This wind is known as the geostrophic wind. So there is convergence of low pressure winds in the near the surface, and they diverge 2 to 3 or more kilometer above the surface. Similarly, going for some distance, they converge at higher altitudes and then sink down and then diverge near the surface. This is how the cycle of convergence and divergence of the wind takes place, and there is movement of wind from high pressure area to low pressure area. Next point, general circulation of the atmosphere. First, latitudinal variation of heating. General circulation of atmosphere due to the latitudinal variation of heating. Second, due to pressure belts. Third, belts migration with the sun. Next, fourth, continents and ocean distribution. Ocean are more in the southern hemisphere and land is more in the northern hemisphere. Fifth point, due to the rotation of the earth during different times of the year, as well as revolution, the pattern of the movement of the planetary winds is called the general circulation of the atmosphere. Easterlies. Next point, its easterlies move from either side of the equator, converge in the ITCZ. In the diagram at 0 latitude, there is ITCZ in ideal conditions. The air cell, the convection cell, which is between 0 and 30 degrees latitude, is called as the Hadley cell. Between 30 and 60 degrees called as the Ferrel cell, and between 60 degree and North Pole is called as the, or South Pole is called as the polar cell. And exactly above the North Pole, it is the polar vortex. So here it is, the wind circulation takes place like the arrows. Next point, warm water in Central Pacific Ocean slowly drifts towards the South American coast and replaces the cool Peru wind current. Such appearance of warm water off the Peru coast is El Nino. The El Nino event is closely associated with the pressure changes in the Central Pacific and Australia. This change in pressure This change in pressure condition over Pacific is known as the Southern Oscillation, and their El Nino and Southern Oscillation combined known as ENSO. So strong ENSO means arid Southwest America, and arid Southwest America get heavy rain, and there occur drought in Australia due to strong ENSO, that is strong El Nino and Southern Oscillation. The arid southwestern America get heavy rain, and there occurs drought in Australia, India, and also floods in China. Next point, seasonal winds. Due to shifting of the regions of maximum heating, pressure and wind belts, there happens to be a seasonal wind. Example, monsoon in the Indian Ocean. So next point is local wind. So land breeze and sea breeze are the local winds. Land breeze occurs at night and sea breeze occurs in the day. Next is the local wind is the next local winds are the mountain and valley winds. Valley breeze occurs during the daytime and mountain breeze occurs during the night time. The cool air of high plateaus and ice fields draining into the valley is called the katabatic wind. So what is katabatic wind? Katabatic wind is the cool air of high pressure plateaus and ice fields draining into the valley. So next point is the air masses. The air with distinctive characteristics in terms of temperature and humidity is called an air mass. So the air with the distinctive characteristics in terms of temperature and humidity is called an air mass. A large air body with a little horizontal variation in temperature. The air mass is a large air body with a little horizontal variation in temperature and moisture. Air masses are classified according to the sources of origin or source regions. So they are generally of 5 types. First, warm tropical and subtropical oceans in maritime tropical areas. Second, subtropical hot deserts in continental tropical. Third, relatively cold high latitude oceans, that is in maritime polar regions. Fourth, very cold snow covered continents in high latitudes, that is in continental polar. And fifth, permafrost of Arctic and Antarctica. Permafrost of Arctic and Antarctica, that is continental Arctic. Next point, fronts. What are fronts? Fronts are boundary between two different air masses. There are 4 types of front: cold front, warm front, stationary front, and occluded front. Occluded front if the air mass is fully lifted above the land surface. Fronts occur in middle latitudes and are characterized by steep gradient in temperature and pressure. So middle latitudes are between 30 degree and 60 degree north and south of the equator. Middle latitudes are 30 degree and 60 degree north and south of the equator. So fronts occur in middle latitudes and are characterized by steep gradient in temperature and pressure. Next point, extratropical cyclones. Extratropical cyclones are associated with polar front and are formed along the polar front areas. Extratropical cyclones are generally associated with fronts. Next point, tropical cyclones. So what are the conditions that are necessary for the formation of tropical cyclones? First, large sea surface temperature with temperature higher than the 27 degrees Celsius. Second, presence of Coriolis force. Third, small variations in vertical wind speed. Fourth, pre-existing weak low pressure area or low level cyclonic circulations. Pre-existing weak low pressure area or low level cyclonic circulations. And fifth, upper divergence above the sea level system. Upper divergence above the sea level system. Next point, the energy that intensifies the storm comes from the condensation process in the towering cumulonimbus clouds. surrounding the center of the storm. With continuous supply of moisture from the sea, the storm is further strengthened. On land, moisture supply is cut off and storm dissipates. The place where a tropical cyclone crosses the coast is called the landfall. The, the cyclones which cross 20-degree north latitude generally recurve and they are more destructive. So the cyclones crossing 20-degree north latitude generally recurve and are more destructive than the normal cyclones. Eye of the cyclone is a region of calm with subsiding air. So the air subsides in the eye of the cyclone. Next point, thunderstorms and tornadoes. Thunderstorms and tornadoes are generally are local storms and are of short duration. So thunderstorms are caused by intense convection on moist hot days. A well-grown cumulonimbus cloud producing thunder and lightning and also produces hailstorms. Insufficient moisture generate dust storms. So if there is lack of moisture, then instead of thunderstorms there is generation of dust storms. From severe thunderstorms, sometimes spiraling winds descend like a trunk of an elephant with great force. So there is descent of the spiraling wind down from above the surface towards the from the atmosphere towards the earth with great force, with very low pressure at the center, causing massive destruction on its way. Such a phenomena is called as a tornado. So what is tornado? So in tornado, from severe thunderstorm, sometimes spiraling wind descend like a trunk of an elephant with great force, with very low pressure at the center, causing massive destruction on its way. Such a phenomenon is called tornado. Generally occurs Tornado generally occurs in the middle latitudes. Okay, generally, not all the times, but generally occurs in middle latitudes. Tornado over sea is called as the water sprouts. So what are water sprouts? The water sprouts are tornadoes which occur over sea or ocean. So the potential and heat energies are converted into kinetic energy in these terms. The potential energy that is stored and the heat energies in the atmosphere are converted into the kinetic energy in these storms and led to the generation of these storms.